Hi everybody, I would like to welcome you to this DevLab workshop today. The workshop is covering converged functionality of Oracle Autonomous Database. We hope you enjoy the content. If you have any questions, please put them in the Q&A box and we will reply live or try and answer in the Q&A box. We hope you enjoy it today, and without further ado, I'll hand you over to Anchana and Justin, who will be running the day.
Thank you, Jane. Hi, everyone. Thanks for joining this call. So in today's workshop session, we're going to talk about the converged functionality of Oracle's autonomous database. So basically, how to gain first-hand experience on using different data types beyond relational data, such as JSON, XML, Spatial, and Graph, all running on Oracle's autonomous database, a truly converged database. So before we begin, let me quickly introduce myself. I'm Archana Durai, Senior Cloud Specialist at the Solution Engineering Hub in Malaysia. I also have my colleague Justin, who would cover this workshop along with me. So for our agenda today, we will be discussing these topics: an introduction to Oracle's Converged database and its features, and then about the prerequisites of setting up a trial account and generating SSH keys, followed by the hands-on labs, such as setting up of compute and autonomous database. So in our case, we're going to set up an autonomous transaction processing database and how to load data into the database and start the application. We will then take a short break if needed and continue to explore different data types beyond relational data, which is JSON, Spatial, XML, and all others, all running on Oracle's autonomous database. And finally, we will wrap it up with a Q&A session. So let's get started. So we all know that the future is data-driven, but how does a business become data-driven? In today's world, there's an ongoing debate in our community about the best approach for developing cloud-native or data-driven applications. But before we get into the debate, let me take a moment to explain what is a data-driven app. So in order for businesses to stay competitive, they need to understand their customers and be able to anticipate their customers' needs. So now the easiest way to do that is to take advantage of data-driven applications that allow you to create value or insights from your data in real time. So what is a data-driven application? Data-driven applications operate on a diverse set of data, which is like spatial, documents, or sensor, or transactional data, pulled from multiple different sources, often in real time, and they create value from data in very different ways to traditional applications. For example, they may use machine learning to make real-time recommendations for customers to detect fraudulent transactions, or they may use graph analytics to identify influencers in a community and target them with specific promotions. Or perhaps they could also use spatial data to keep track of deliveries. So data-driven applications are often built using data-driven development methodologies, including things like microservices, events, API-driven development, and also low-code development, as well as needing to be delivered using continuous delivery. So the requirement of modern applications has led us to two very different approaches. So the first one being, do you use multiple single-purpose databases, also referred to as the best-of-breed databases, which means like you have each of which is specialized for a specific data type or workload, or do you run a converged database that supports all data types, all data models, and all workloads? So let's take a look at each of these approaches in detail using a real-world scenario. So imagine you have just been asked to set up a document store for an urgent new project. So with a single-purpose database approach, you would find the best-of-breed document database and provision that for your new project. So at a first glance, this single-purpose database approach will appear to be a good option. The developers are happy because they got exactly what they needed to begin the project. But as often happens, an unforeseen business need may pop up, where we now need to run analytics on this document store. So unfortunately, this single purpose database does not offer very good analytic capabilities. So now we are going to need a separate data warehouse. So we will then provision the best of breed data warehouse. And once it is provisioned, the developers will actually need additional application code to propagate data from this document store to the data warehouse using event streams or ETL processing. A little while later, again, the business might now require the need of incorporating machine learning into their application. So a third single purpose database must now be provisioned. And this in turn again requires complex application codes to be written to move the data across the different single purpose databases. So in fact, you will need several single purpose databases even for a small application because they need multiple data types and workloads. And also, these single purpose databases are going to end up fragmenting your data because it's going to require more complex application codes to be written and maintained to keep all of these databases in sync. And each single purpose database again might require ongoing tuning, patching efforts, troubleshooting, scaling, etc., which will again in turn require specialized skills and unique management tools. And you might also need application code or skills within your organization to make sure each of these single purpose databases are secure, scalable, and highly available. In addition to this, you might also experience a steep learning curve with regards to these single purpose databases because each database requires the application developers to use their own proprietary APIs or languages instead of using a standard like SQL. And these proprietary APIs can often lead to applications getting locked into a single purpose database or cloud provider because no other database is going to use that same API. So on top of all these complexities for the single purpose databases, your organization must also bear the brunt of a large integration work that is required to make the single purpose databases approach feasible on a large scale. So you will need skills and personals who are knowledgeable about the operational aspects of each single purpose database. Your security policies will have to be re-implemented in every database, and your applications will now be more complex to deal with propagating data between the different single purpose databases. So in a nutshell, integrating the single purpose databases has become a job that never ends. So developers become focused on integrating these fragmented single purpose databases to create a scalable solution instead of investing their time in innovations. So there must be a way to make the data-driven application and development and deployment simple, isn't it? So well, here at Oracle, we want to make this deployment and development simpler. And how do we do that? We want to do this by providing you the synergistic development paradigms or methodologies. And we also want to eliminate the data fragmentation, which is introduced by multiple single purpose databases by offering support for all the data types and data models in a single converged database. And we also want to make it easy by providing a uniform API for all those data types that are going to be used. So in a nutshell, Oracle's Converged database is a multi-model, multi-tenant, and multi-workload database. So by multi-model, I mean it provides native support for multiple data models, including JSON, XML, spatial, and graph beyond relational data. And multi-tenant means it is a container architecture in the data tier, providing consolidation, isolation, and agility for databases, which is a much better match to the containerization in the app tier. And multi-workload means providing a wide array of optimizations for different kinds of database jobs like running parallel executions for machine learning or fast in-memory commits for streaming data from sensors. So with Oracle's Converged database, companies can give both developers and CTOs what they want meaning they could improve both developer productivity as well as the data productivity at the same time. And lastly, what's great about this Oracle's Converged database is that it is available everywhere. You can deploy it on premise, in the cloud, or clouded customer. And because it's identical, you have the added benefit of ease of movement of these deployment options. And there's no need to re-engineer your existing applications. So to summarize, we all know that managing an IT environment consisting of multiple single-purpose databases is going to be time-consuming, resource-intensive, and expensive. So Oracle's Converged database helps to alleviate these challenges by supporting multiple data models, multiple workloads, and development approaches within a single database, significantly reducing the number of technologies required to deliver an enterprise class application. So with this, we are done with the short introduction about what is Oracle's Converged database and its benefits. We will now move on to the actual live labs workshop. So before we get started with the labs, I would brief you about the prerequisites of setting up a trial account as well as generating SSH keys. So I'm going to walk you through the steps of getting an Oracle Cloud free tier account and how to sign into Oracle Cloud account. Let me just show you. Yeah. So Oracle Cloud free tier by the name, it allows you to sign up for an Oracle Cloud account, which provides a number of always free services. And it comes with and a free trial, which comes with $300 USD of free credits on all eligible Oracle Cloud infrastructure services for up to 30 days. So let me quickly walk you through of how to create your free trial account and get started. So you can go on to oracle.com/cloud/free on your web browser and you can click for start for free. So once you do that, you will land up in the registration page. So under the account information, you can enter your details like country, your name and email. Make sure you give your valid email address. And once that is done, you can click on the verify my email button. So once you click on this, you will get a pop-up message saying that an email verification link has been sent to your inbox. And you can go back to your inbox and check. You would have received an email from Oracle Cloud asking you or requesting you to confirm your email address. So you can click here to validate your email address. And once that is done, it takes you back to this account information page where you can input your password. So make sure you follow the password specifications as indicated on the screen. And you can give your company name, which is an optional step. And next comes the cloud account name, which is something called as the tenancy name or the cloud account name. So this will be automatically generated based on the inputs that you've given so far, but you can also feel free to change up to your wish. But make sure to remember this cloud tenancy name or cloud account name because this is what is needed to sign into your Oracle Cloud account later. And next comes the home region. So make sure you choose your home region correctly because this cannot be changed once you sign up for your Oracle Cloud account. So once this is done, we go to the address information page and you give your address and then click on continue. And then comes the mobile verification page. You choose your country code and give your mobile number. So this step is actually required only if your email address cannot be recognized. So once the mobile verification is done, you would go to the payment verification. You would basically add your payment verification method to be a credit card. You will enter your information and all payment details. So kindly note that this is a free credit promotion account. You will not be charged unless you elect to upgrade the account. So this is specified over here. So once this is done, your payment verification is done. You would just have to click on this checkbox, review and accept this agreement, and then click on Start My Free Trial button. So once this is done, your account gets started provisioning and it should be available shortly for your use. So when it is ready, you will be automatically taken to the sign in page. Meanwhile, you will also receive two emails from Oracle. One email with the initial notification telling that the provisioning is underway, and the other email will be a notification after the provisioning is complete. So this is just a sample email for you, like your cloud account has been provisioned. So now let me go back to my browser. So go to cloud.oracle.com and you can enter your cloud account name. Remember, this is the tenancy name that we gave while signing up for a cloud account, and then click on next. So you will land up on the direct sign-in page or the SSO sign-in page. Like, you have options to choose between SSO or direct sign-in. So in my case, I'm going to go ahead with SSO and click on continue over here. So you will then land on the page where you need to enter your cloud account credentials. My username will be my email address. And once you give your credentials, click on sign in. And that's it. You're now signed into your cloud account. So we are done with the prerequisites of setting up a trial account. And get started with the hands-on labs. So before we begin, I'll just briefly describe about what the lab is. So this workshop basically uses a hybrid cloud architecture, meaning you have a web application running in Docker on your Oracle Compute instance, which is again connected to your autonomous transaction processing database. So you will set up an autonomous transaction processing database using Terraform, load the data from the dump files, and then connect your application server and query multiple data types in the same database. So you will also need to use Oracle SQL Developer Web to execute certain commands or SQL queries associated with this lab. So I've already posted a step-by-step lab instructions for your reference over the chat. So you can see here the link that has been posted already. So feel free to refer to them and get back to us with any questions that may come up later. So let's begin. So the first lab is about generating SSH keys. So the SSH, or the Secure Cloud Shell, is a protocol or method for secure remote logins from one computer to another. So SSH keys are very important to securely access your cloud instances, your compute instances in the cloud. So for this workshop, I will show you like how to generate an SSH key using Oracle Cloud Shell. You can also use other methods like using a partition tool to generate your public and private keys on your local desktop. So for this workshop, we are going to see how to generate SSH keys using Cloud Shell. Let me go back to the OCI console. So what is Oracle Cloud Shell? It's nothing but a browser-based, and it does not require any installation or configuration of software on your laptop, and it works independently of your network setup. So how to launch the Cloud Shell? So you can see this Cloud Shell icon on the top right corner. So click on this. So this Cloud Shell is nothing but a small virtual machine running a bash shell, which allows you to which you can access through the OCI console or homepage. So it comes with a pre-authenticated OCI CLI command line interface set up on the console tenancy homepage region. And it also has all the up-to-date tools and utilities. So to use this, you must have the right or the required IAM privileges, which is being granted by your tenancy administrator. So once the shell has started, we can now enter the following commands to generate the SSH keys. So make sure you choose your key name appropriately, because this is the key name which you will use, or this is the key that you're going to generate, which you will use later to connect to your compute instances. So I'm currently in my home directory. I'm going to create a directory.ssh, and then I cd to that directory. And now I'm going to create my SSH keys. So I'm going to give a name like Cloud Shell Key. So once you run this command, it'll prompt you to enter a passphrase. So I'm going to just press enter twice. And that's it. You have your key generated. You have two keys generated. One is the public key and the other one is your private key. So make sure you copy the contents of your public key and save it somewhere, because this is later needed while provisioning or setting up the compute instance. And make sure you do not share your private key with others. To see the contents of the public key, you can do a cat command and then followed by the public key name. So this is your public key, which you will be later using on how to set up your compute instance. So with this, we are done with lab number 1, which is generating SSH keys using Oracle Cloud Shift. You can also use other tools, like I said, mentioned earlier. You can use Patigen to generate your own private and public keys on your local desktop. So let's move on to the next lab, which is setting up compute and autonomous database. So in this lab, I'm going to show you how to set up a resource manager stack that will actually generate the compute and the autonomous database and the networking components needed for this workshop. So the compute basically has 2 Docker images running the eShop application, which we're going to use for this workshop. And these Docker images will connect to your autonomous database. And you will then connect to the compute instance and import data into your autonomous database. That is required for the eShop application. So for this workshop, for this lab, we are going to use the autonomous transaction processing database. Let me go back to the lab instructions to show you where to download the zip file that is required for the setting up of compute in autonomous DB using Terraform. So you can go to navigate to lab number 1 and task number 1. So here on the first task, like you can click on this link below to download your resource manager configuration file, which you will need to build your environment. So let me go back to the OCI console and show you. So you're on your homepage. I'm going to minimize the Cloud Shell. Click on this hamburger menu on the top left corner and go to Developer Services. And under Resource Manager, click on Stacks. So you are on the Stacks homepage. Make sure you're in your right compartment. So in my case, it's going to be Workshop. And make sure your right region, your desired region is chosen. In my case, it's going to be Tokyo. And then you can click on Create Stack. So the first option is going to be the origin of my Terraform configuration is going to be my own configuration file that I'm going to upload for this build. So I will go with the option of my configuration. And what is going to be the source? The zip file, which I've just downloaded in my previous step. So you can select zip file and click on browse. And you have the zip file already. So I'm going to leave the other inputs to the default, like other inputs like the name of the stack, the description, and everything else to the defaults, and click on next. Next, we come to the main configuration page. So the instance count, again, I'm going to leave it to the defaults of 1 because I do not want to create more than 1 instance. So in your case, if you need more instances, you can give a number as required. And then the next option is to choose an availability domain. So I'm going to choose my availability domain. This is nothing but the data center region where you want to have your compute and autonomous instances hosted. And next comes the SSH public key. So remember, like we generated a SSH public key using our Cloud Shell in our previous lab. So this is the key which you will be copying and pasting into the SSH public key box. You can also use your locally generated public keys. So I've already saved it over here for the lab. So I will be using this one. And once that is done, we're going to go for the options of choosing our instance shapes. So you have two options here. You can either go with flexible instance shapes or a fixed instance shape. So I'm going to go with my fixed instance shape. So for fixed instance shape, you would have to go with a VM standard E2.2 or higher. So I'll leave it to 2.4. And I'm not going to check this option of using my existing VCN because I want this setup, this Terraform or resource manager stack to create a new networking component for me. So I'm going to leave this as such and then click on next. And the final page is reviewing. So you will review the inputs that you have just given, the availability domain, the SSH keys, and if you wanted a flexible instance or a fixed instance shape, and then click on create. So in order to save time for our workshop, we almost have like 7 labs. So I have already created this stack for you. I will just go back and show you. So once you click on create, this is how the stack will get provisioned, and this is how it will show a status of active once it has been created. So once that is done, you can see under resources, if you navigate to resources, and under that, if you navigate to variables, you can see all the variables that you have given while creating the resource manager stack. So we gave our region, we gave our instance shapes, which is like shape use flex, which is going to be false because we went ahead with a fixed instance shape. And what is the instance shape? We went ahead with standard E2.4 and our availability domain region and our public keys. So if everything looks okay, you can then click on Terraform apply. Terraform plan is again an optional step if you want to do before even you do the apply. So if you click on apply, it will generate a default apply job name. You can leave it to the defaults and click on apply. So I've already provisioned the resources needed for this workshop. So I'm not going to click on apply. Let me show you the job and how it looks like. So once you click on apply, you will see a apply job generated. You can click on this job name and you will see the logs getting auto populated with what is happening in the background. So you can monitor these logs to see like how the environment is getting built. So at the end, you will see a message like apply complete, and you have 10 resources added to your environment. And make sure like you note down these outputs. It will give you the password of the autonomous database admin user and the autonomous database OCID. And you also have your instance name as well as the public IP address of that instance. You can also navigate to the hamburger menu again and go to compute and click on instances. So you can see your instance that has been provisioned as part of this stack, which is up and running with IP address, public IP address. And you also see like this is the virtual cloud network that the instance uses. So you can click on this. So as part of this Terraform resource manager stack build, like you would see the VCN, the networking component is also provisioned for you with all the needed subnets. You have the public subnet, which this instance is using. And you also, the public subnet has a security list where you have all the rules needed, required for the workshop already built in for you. So once this is done, we can go back to the hamburger menu and click on Oracle database to see if our autonomous transaction processing database has also been created. And here you go. So you have our autonomous transaction processing database, which has been created. So it's with the default number of OCPUs, like 1 OCPU count and 1 terabyte storage, and it's a 19C database, and it exists in our workshop compartment. So with this, we are almost at the end of lab 2, and I will show you how to connect to our compute instance using PuTTY. So I've already made the note of the public IP address. So I would just log in. You remember when you log in using your PuTTY into the compute instance, you would have to input your private key. So this is my private key that I've locally generated. So once that is done, click on open and your username will be OPC. And that's it. We're connected to our compute instance. So with this, we are done with the lab 2. Moving on to the third lab, which is about loading data and starting up your application. So for this one, we will follow several steps. In this lab, basically, we have already created a compute instance, the networking component, and the autonomous database in the previous lab. So in this lab, you will run an import script to import data from your object store into your autonomous database using Oracle Data Pump. And your data, imagine your data was previously residing in several single purpose databases. So in this lab, we will show you how to centralize your data into one database that your application can read from. So the first step to do that is to create an Oracle wallet. So what is an Oracle wallet? So it's a client credentials file that is needed to securely connect to your autonomous database. So in the workshop instructions, they would have given steps to generate your Oracle wallet using the command line, the OCI CLI. So I'm going to show you how to do it over the OCI console. So I'm on my autonomous database details page. So click on DB connection. And then you can see you have two wallet types for the autonomous database. One is the instance wallet and the other one is the regional wallet. So instance wallet is something which is specific for this particular instance. And regional wallet is something which has all the wallets for all the instances residing in a particular region. For example, Tokyo in my case. So I'm going to leave it to the defaults and then click on download wallet. So once you click on this button, it'll prompt you for a wallet password. Make sure to follow the password specifications indicated on the screen and then click download. So once you click on download, you will see something like this. You will have a Converged wallet zip that is being downloaded onto your local desktop. So with this, we are done with the first step of how to create an Oracle wallet. Then let's go to the next step of creating an auth token. So let me go back to the console. And in the workshop instructions, again, they would have given the steps to create an auth token via OCI CLI. So I'm going to show you how to do it using the OCI console. So on the top right corner, you can see a user icon here. So click on that icon and click on user settings. So this is my user page. So auth tokens are basically Oracle generated token strings that you can use to authenticate any third-party APIs that do not support OCI's signature-based authentication. So every user will be able to create their own auth tokens, update or delete. Okay, and every user can create or have a minimum of 2 auth tokens. So you can navigate to the resources menu and under resources, you can click on auth tokens. I already have one created, so I'm going to show you how to do it. Click on generate token and you can give a description. And then click on generate token. So once you click on this button, you will have a pop-up window exhibiting this auth token value or string that has been generated. So make sure you copy the string onto your notepad because this is needed for the later steps. If you do not copy and if you click on close, you will not be able to retrieve the string later. So make sure you make a note of this string onto your notepad. So once this is done, The next step is to connect to your SQL developer and create credentials. So let me show you how to do that. Let me go back to the hamburger menu in Oracle database and to my autonomous transaction processing database page. So I'm going to click on my autonomous transaction processing database page, click on the tools tab and click on open database actions. So this will open up a new window, which is basically the SQL Developer Web window where you sign in with your admin user, click next. And this is the password that you would have retrieved once your resource manager stack was complete. Welcome 123. And then click on sign in. And you're signed into the SQL Developer Web page. So you can click on SQL here. And now I'm going to execute a code to create the credentials that is required to access the object storage. So what I will be doing is I already have the code. So I'm going to just copy paste it for you here. And we're going to use the DBMS Cloud package, create credential procedure. You give a credential name, and then the username is admin, and the password will be your auth token value that you generated in your previous step. So let me bring that up for you. Yeah. So once you run the script, your credentials will get created. So for this lab, I had already created the credentials. So that's why you would see a message saying the credential already exists. Okay. So you can ignore that. So once the create credentials is done, we are now going to load the data from the object storage into our autonomous transaction processing database. So let me show you how to do that. So, but before that, we downloaded the wallet, right? So what I'm going to do is I will be using a WinSCP to move the wallet file to my compute instance. So I'm currently connected as the OPC user and I'm under my home directory. So I've used WinSCP to move my Converged wallet, the wallet zip file from my local desktop to the compute instance. And from there, I would also copy this wallet file to the Oracle user's home directory. Okay, so I've already copied the wallet file. I've created a wallet folder under the home Oracle location, and I have unzipped this wallet file into this folder. So once this is done, we would go and download the script from the object storage. So I will show you how to do that. I've already done that for you. So before even you download the script, you would be setting up the environment for your Oracle user. You will do a Aura env command and you would give convert CDB. So once the environment is set for the Oracle user, you will give this command. So all these commands and everything are being recorded as a step-by-step instruction in the workshop link that I've already provided to you. So once you run this wget command, so this command is basically downloading the load script or the import script for you into your compute instance. So once the script has been downloaded, you would change the permissions of this script. You will give execute permissions and then you would execute this script. This is basically required, like you would have to import data into your autonomous transaction processing instance. So when you run the script, you will give two inputs. One is the admin user's password and the name of the ATP instance. So once this is done, the script will basically call in the Oracle data pump import internally, and you will see the script progressing. It will usually run for around like 5 to 7 minutes. And you might see some warnings related to the DBA role. So these warnings can be safely ignored because this role does not exist in your autonomous database. So once the script is done, so it'll basically load several application schemas and also create SQL Developer access for each of these application schemas. So once the script is done, we will log into our database and verify the data has been loaded. I'm going to set my environment. And I'm going to export my TNS admin variable to the location where I've stored my wallet file. And then I will launch SQL Plus to log into my database. And I'm going to query one of the schema tables that I've imported data into. So that's it. So this verifies that we have already imported data into our autonomous database. And the last step is going to be, how do we bring up the Docker application, the eShop application, basically, to connect to our autonomous database. So for this, we are going to again download a script, an environment script. So this script is basically going to download the Docker containers from your Kubernetes engine and bring up the eShop application required for this lab for you. So we will go to U01 script location as Oracle user. And then we would run this command. We would again download the script from the object storage. So we will be running this wget command. And once the script has been downloaded, we will again change the permissions for this script to execute. And then we will execute the script as Oracle user. So this is basically going to download your Docker applications from OKE, and it's going to bring up the eShop application for you. So at the end of the script, you can see here, like you have two container images, which are having a status of online. And you can access the application using this web browser URL. Okay, let me show you. So this is our eShop application that has been set up on Docker. And this will connect to our autonomous database, which is a converged database having all the multiple data types. So with this, we are actually done with labs 1 to 3. And let me pass it over to Justin to cover the second half of the workshop. Over to you, Justin. Thank you.
Thanks, Archana. So let me share my screen. Can you stop sharing? Sorry, Archana.
I've stopped sharing.
Okay. Yeah. Yep. Okay. Thank you. So good afternoon, everyone. So my name is Justin. So I will help you to discover more on the next lab 4 until lab 7. So before going to lab 4, this is the agenda for the lab 4. So you already know that the Converged database supports multiple workloads. So JSON is the one that I want to mention first. So the step is now we will connect to SQL Developer Web, access to JSON, and then we do some command like insert, update, and some query that we can do on JSON. Okay. So let me switch to my console. Okay. So to access to the autonomous database on the home page, you can go to hamburger menu, go to Oracle database. This autonomous database data warehouse over here. So when you go here, remember you remember to check on the compartment. Before launching the Terraform script, you already chose the compartment. And here, at this example, this is the workshop compartment. So remember to choose workshop compartment. And okay, let me refresh it. Oh, sorry, maybe got wrong one. Sorry, transaction processing should be this one. Okay, it should be transaction processing, not autonomous data warehouse. Okay, so this is the ATP autonomous transaction processing database that we already created with the Terraform script. Okay, now I click on this one. So to access to the SQL Developer, there's two ways. One is using SQL Developer installed in your laptop or a computer. The other way is we have a tool here we can go to tools, and there is database actions over here. So we click on this one. This is basically open the SQL Developer on web, so for you, so you don't need to install any other application if you don't want to. So here, let's say I log into the admin. The password we already shared before is welcome123. So I just copy and paste over here, log into my SQL Developer. Okay, and this is the page. Okay, to go to the query, I go to SQL on the first left hand side. Okay, and this is the workspace. Okay, on the left hand side, you can see there is on the schema list down here on this ATP on the table objects you can view from the left hand side. So currently, remember before going into lab 4, there is a step that I want to remind you. There's a step over here. Okay, this is lab 4. The link I already shared on the chat, so you can check it later. So basically, before going to lab 4, we need to go to the first task of lab 4. You need to go to appendix 1. Make sure that there is some running command over here. You need to run it before to make sure that you can get the access to the application, to the browser for the JSON. Okay, so copy these things. First one, the second one, and then rent the access. Okay, so for the purpose of the demo, I already have it here. So let me open back my browser. Okay, I already load it over here. For all the command is here. I already run it. Okay, so not only lab 4, for the lab 5, you also need to run the similar command, but for the other application, for the other workloads. Okay, so after running all those things, you go to the task 1 of the lab 4. It means that connect to the SQL Developer to the JSON. Okay, so now I duplicate my website, and then over here, you see now I log into admin. Now I need to change it back to the app JSON. Okay, like this. Okay, enter. Okay, now I need to log in again. And now the username is not the admin anymore. Okay, so just for the reminder, you can come back to the website, the web over here, and see that. Okay, to connect to the application, you use the username app JSON. Okay, and the password is Oracle for you. Okay, so let me copy this password. Come back to my console. It's app JSON. Okay, and then the password. Okay, so now I log into the web browser to pick the app JSON schema. Okay. On the left hand side, there is some database data already loaded when we run the Terraform, and also when we run the container script to create the containers for the application. Okay, so now what is the next step? For if after we connect to this SQL Developer, it means that we successfully log into the database, we can do some query. Okay, the first, let's say I want to check some information on the purchase order, the table I got from left hand side. I run and select the count. I see that there is some data inside already. Okay, 10,011. Okay, so now the next one is I will run the command to insert the records. Okay, so I will make it smaller over here for you to see the whole thing. Okay, so basically this is quite similar to the SQL command. You insert something into the purchase order, the table. Okay, the value is listed down over here in the JSON format. Okay, there is a PO number, the reference request, the requester, user, everything is is listed down here. Okay, so now I run the command to insert this information to my table. Okay, remember now we have 10,011. I run this one. Okay, success. Okay, now I run count it again. Okay, there is 10,012. Okay, I successfully insert a new value inside my table. Okay, so let's do some basic command for the JSON. I had the select star for purchase order, and I put a tray here. Okay, so tray.po document, I want to see all the PO number with the ID 10,001. I run, and you can see on the PO number that got 10,001 is listed down over here, and it's in JSON format. Okay. So let's say if I want to update some information similar to the SQL command that we used to know, we update the purchase order. We set the some information like requester is now I want to change from the original to this name, and I need to have the ID number from this one. So let's say I choose this number over here, copy, put it here. Okay. So the requester from Sarah Bell should supposed to be changed to MS node. Okay. Now I run again. This one. Okay, successfully run. So now I want to see the data. How was it now? Okay. So the requester from Sarah Bell already changed to MS Donny. Okay. Some other the query that I can show you how easy we can work with the JSON in Oracle database. So this is the other SQL command that you can see. We select all the information from reference requester, cost center, and from the purchase order. The condition is now I just want to see on the shipping instruction, on the document related to shipping to South San Francisco. Okay, and simply we just run the command and we see that, okay, on the shipping instruction, go to San Francisco. It's listed down here. Okay, let's say if we want to know more, okay, I want to see what is the product that will be shipped with the UPC. UPC is sort of universal product code. So I want to know that this UPC number and any other PO number related, any order related to this PO UPC code. I also run the similar command over here. I hope you can see. Okay, and they see is everything listed out related to this UPC code. Okay, this the first thing I want to say that for the JSON, you can apply quite similar command, SQL command that you used to know with JSON to work on this one. Okay, so now I want to do something more specific. I want to find the PO number 1000. Okay, and who are they? I want to know all the information of this customer. Okay, I run this command. Also, the data is from purchase order. Okay, and the UPC code is this is the old one. Let me copy and delete the old one. Okay. Okay, sorry. This is from purchase order, and this on the column that I want to list down with the PO number 1006. Yep. For this PO 1600, this is the requester is this guy with all the information listed out over here. Okay, so if let's say I want to have something more specific, like I want to create a view for the purchase order, I can use this type command. You can see, you can create a view from purchase order and put on the command and value map to the name, the new name, like this. Okay, let's say for in the example that you can find inside the lab, this is the one of the command. Okay, I want to create a view. I run this command to create a view. For this, I also have the other command to create the other view for the purchase order. Okay, the purchase order detail for for this kind of request. Okay, similar. I run the command. Okay, successful. And now I want to query. So you can see that based on the view that we just created, we can select the PO number, reference instruction. It's more shorter than the things that we normally use for the JSON in the beginning. Okay, I want to query with the requester Stephen King with the quantity more than 7, unique price more than 25,000. Sorry, $25, and then we get the result similar in the table, easy to view. Okay, on the unit price, on the quantity more than 7 of this specific user, Stephen King. Okay, and there's furthermore example that you can find inside the lab that you can explore more. Okay, so for JSON, the simple way to use and the simple way that you can connect and use with the Oracle database. Okay, so now I want to switch to lab number 5, Spatial. Okay, besides JSON, we also support Spatial, where you can let's say you have the requirement that, okay, I have a lot of data from the customer location, and now I want to map the location with my nearby, my nearest warehouse. Okay, so it means that you can faster delivery, so you can save a lot of costs for the transportation. So for the Spatial, you can do that thing. So similar to the lab 4, I will connect to SQL Developer, and then I run some environment setup for Spatial, and then show you how to query with the Spatial on Oracle database. Okay. Now back to my SQL Developer. Okay, I will use instead of app JSON. Now I need to change it to the app Spatial. Okay, it should be app Spatial. Okay, this is okay. You change the admin or app JSON to app Spatial over here, and I enter. I also need to log in. The username, of course, the now app start. Okay, the password is Oracle for you, Oracle underscore for you. Yep. Log in. Okay, so in the lab, in the guidance, you can see that we have the first create a table over here. Actually, we already created, but somehow if there is some mistake or some error that you can see the table, you can create it again. So in this case, I already have, so I will not run the command again. I just simply execute the data. Okay, so now I will insert the data, add the data to the customer. Okay, there's customer table over here, you can see, and with the customer geolocation is the columns, and the value is in array. Okay, this is on the value for longitude and latitude, and this number is a reference number to the spatial reference system ID. It's like a foreign key to an Oracle dictionary table that contain all the supported coordinate systems. So you can put the number over here. Okay, and similarly, I also skill to run the to add the information for the table warehouse, the column geolocation, similarly to warehouse BTP, and you can see on the table on the left hand side already populated. Okay, now I run and execute to update the information. Okay, now I want to create the index for all the information that I just keyed. Okay, with this command, create index. Okay, so now it seems like I'm ready to run some spatial queries. Okay, so the query is also similar and simple in the way that you can select the customer ID, customer last name, gender from the warehouse, and what I want to see is on the warehouse near with the name Fundel facility. Okay, and I just want to see it find nearest. Okay, find nearest customer near the Fundel facility, meaning that near this warehouse. Okay, find customer near this warehouse. Okay, and I run. Okay, based on the information that I have, okay, these are the customer nearby this warehouse. Simple, right? Okay, so we do something more in advance. Okay, select the customer information where also similar nearby this warehouse. Okay, this is the name of the warehouse, and I just take 5 of them. But please order them sorted in the distance in mouse. Okay. Okay, so there's the customer nearby this Livonia facility, and over here is the distance in mouse from the warehouse. Okay. For the more advanced, I have the other example. Let's say we want to see more specific in the distance. Okay, similar. I also select on the information from the customer, from the warehouse, where the warehouse is also named Livonia facility. Okay, and then I have the distance be now limit just to 100 miles. Okay, it means all the customer nearby, but now I want to see on under 100 miles, and these are the list that we have. Okay, these are all the customer nearby this warehouse within 100 miles. Okay. Okay, so now I have the order request. How to find all the customer inside a 30 minutes drive time. Okay, so it meaning that I have a warehouse in the city and I want to know all the customer within 30 minutes driving. Okay, so I can use this kind of command. Show you. I also select on the customer information that I needed, and the information is now drive time minute under 30. Okay, and this is the command to run inside to find. Okay, and you can see on the customer ID. Of course, this is just customer ID and warehouse. You can add in more the name or the address of the user, and on the warehouse name that you can say by. Okay. Okay, so it's simple, right? For lab 5, that's what I can show you for now. You can explore more on the lab that I share to you on the link. Okay, so we move to lab 6, SODA. Okay, so what is SODA? Okay, SODA is a sort of simple Oracle document access. Okay, it's a set of NoSQL style APIs that let you create and store collection of documents. Okay, in Oracle database, and you can retrieve them, query them without needing to know SQL command or how to document how the documents are stored in the database. So with SODA, it means that you can use some kind of like in my example, next example, you can use Python, to strip and query the data without knowing the SQL command syntax. Okay. So firstly, I need to, if you want to go to Python, now I switch back to my console, and now you can see on the left hand side over here, right hand side over here, there's a Cloud Shell. Okay, you click on this one. If you open the Cloud Shell command for you. Okay, so over here I already got my command ready. So now I want to check my Python version UI6. Okay, it's now version 368. Okay, I'm ready to go. Okay, so to connect with the Python, I need the Converged wallet that will help me to connect to the ATP database. Okay, I already have it here. So now I will unzip it to use it. I had a command here to unzip the wallet. Okay, it will unzip this zip file to the folder named wallet. Okay, enter. Now I list and I see that there is a folder named wallet. Okay. Now I cd to this wallet, and I will need to modify the file on SQL net.ora. Okay. Here, you need to modify this file because currently in the default, it doesn't show where to connect to the wallet. Okay. So the wallet location currently is wrong. It's not network admin. It's supposed to be the home and your username and the wallet that which I just instructed to. So now I change it to home. Okay, my file name and the wallet. Okay, and I delete everything else. Okay, okay. So good to go. Escape. Click on escape and click on write and I click. Okay, enter. Okay, double check. SQL net.ora. Okay, I got this correct. Okay. Okay, so now we already configure the necessary connection to the database. Okay, so now next one, we want to check the connection. So there is the file that I already prepared here. I can show you with soda1.py. Okay, let me list down. Okay, sorry, should be over here. Okay, I already prepared some file over here for this lab. Okay, this Python file is running using my connection that I just configured, and it will show all the connection information like the database version, and it will ring out. Okay, so how to run this? Okay, the command is simple. Python 3. Okay, soda 1 pi. Okay, it will show me the database version of my ATP 19.12 for 0 for 1 for 0. Okay. So now I want to insert some information to my soda database. Okay. So soda connection to my database. How do I do that? Okay. I had the other one. Okay. So all the file that I have here, you can find on the lab. So I just want to simply show you how does it work. Okay. So this file that I have here called soda2.py. I also use my connection. I define some connection over here. This file basically will do the it will check if there's I have the table called create connection over here, and then if there's some information inside, it will clean up to make sure that I will not be overlapped with the data that I have. It will then insert to the table some information like name is blue, that is crew, status is indentured. Okay, and then it will display so all the information that it just inserted to. And similar to the first one, Python soda2py. Okay, and then you can see beside the database version, like the first one, I also got the information that I just inserted to my soda document, name, blue, that crew, status, and then okay. So to make it more complex, okay, now I want to show you the how to insert more information inside of the quickly soda. Okay, so I also have the other file soda3 part. Okay, it's more longer and it for a little more complex. Okay, similar in the first and second one, I also had a connection. Okay, I create a connection to the soda. Okay, to the database, and then I insert some information. Okay, now I insert more with the name I insert four more values inside. Okay, with all the information. So I want to notice something like, okay, I want to later query some the information that related to this plankton. Okay, and from here I have two value that got the plankton that the plankton information inside. Okay, so later when I do a query, I supposed to see two rows returned to my query. Okay, so I insert 4 and I query for just only 2. Okay, and now I run this one, Python tree, sorry, Python tree, soda. Okay, soda tree, .py. Okay, and then okay, it already insert to soda document, and this is the key. Okay, so basically I have this one, and this one is the ID for the third and the fourth of my value. Okay, now I run the command and I suppose to got the return with those two keys. Okay, the command is okay, similar, connect to my database, and then I want to query. Okay, bring on the wells with the diet, which include plankton. Okay, okay, and then this is the query that I have to that, and when I look at that, I find any works similar to plankton. Okay, and then I get it bring out. Okay, similar plankton soda for .py, and you can see there is two value return over here, like I already show you at first. This is the record that got the plankton information inside. It's DAC 626. Okay, and you supposed to be DAC 626 over here. Okay, so this is the way that you can query the information in the database without knowing the SQL syntax. Okay, so now if you already know SQL, how do you work on the database? So I will back to my SQL database actions over here. Okay, so instead of now up Spatial, I will connect, and its name is now is not Spatial anymore. It will be the sorry, for this one you don't need to log into this one. You just use back the admin. You can see on the admin. So now I want to refresh and see what is inside of my admin. Okay, so I will back to my admin with the username and password. Over here, username is admin, password is welcome 123. Okay, and I log in. Now I see on the left hand side I have the soda collection that I just created before. Okay, if I want to query, I want to select and show all the information inside and run the query. See that all the information that I just inserted now should be shown here. Okay, so you see, I first insert one value and then the other four value, and everything is listed out over here. But you notice that on the JSON document, it shows just blob. So it means that in this kind of soda, you maybe the information that stored in JSON, you cannot view on this way. So you need to run the command with the with the way of JSON to show all the information. So now I have the command over here to select the ID with the JSON series to show all the information inside this one. Okay, and then now I got more information for the JSON. Okay, in the JSON format. Okay. Yep. Okay. So the next one I want to show is the XML, the way that we can work on XML, similar to the way that we work on JSON or Spatial or Soda so far. So with this one, I concluded my lab 6 Soda. At lab 7, similar, we have to connect to SQL Developer Web. We use some query on XML. We do some insert, update, and some query to show the data. Okay, so back to my console. Now we move to lab 7. Okay, to connect to SQL Developer, similar to the Spatial and JSON. Okay, I use this tab. I will change this name is not just XML. Okay, remember this is admin. Now I change to app XML. Enter, and I need to log in. Okay, the username is at XML, and the password is Oracle per you. Say, okay. Okay, so to query with the XML, I also have similar syntax. You like select count. This is basically will show the number of records in this purchase order table. Okay, I will run it. And so, okay, I have 10,003 records inside my table of purchase order. Okay. Now I want to view some information inside by using this query. Okay, I want to query the object, the purchase order that will have the row number number one. Okay, just show any row over here. Okay, we see the row number one, information of row number one. Okay, so if I want to see more information, like I want to see not instead of one, I want to see something more. Okay, I want to see all the row number less than 5. Okay, instead of showing everything, I just want to see 5 first row. Okay, and then see on the 5 first row will be listed outside. Okay, with the information of a purchase order. It's the way that you work on XML. Okay, now I want to I want to insert the query. Okay, so firstly, I will run the command again to count how many rows that I have. Okay, this is 10,003. Okay, I have the you can file this file in the link on the lab. Okay, this is basically help you to have the query to insert the one record inside the purchase order in XML format. Okay, this is all the information that you have. Okay, and then I just copy inside, put it here. Okay, see that all the information is in XML format. Okay, I click on insert, and you can see there is the new record will be inserted to the system. Okay, yep, already done. So now I check number of records that I have. So 10,004. So I successfully have new records inside my database. Okay. If now I want to do some update on the file. So similarly, you also have this file, this command in the file that you will download later. This is basically to update the purchase order. And instead of the name is vColi over here, we will update the object with the reference ID 202 something to vColi. Okay. Now let me delete everything over here and then place this one to update the information. Okay. Yep. Okay. And then I will check it again. To show all the information that I have. Okay. It may be too much to file, so let me show you the records. Okay. Okay, so now it's more easier for me to just run the command, just view the information just about this reference number 202. Okay. Okay, so this is all the information that I can extract it from the database about weekly. Okay. That I have the more advanced query. Okay, this is the query to help you to get all the information about the purchase order that more than 29 of $95. Okay, so all the purchase order that more than 27.95. Click on this one. See, this is all the purchase order that have the cost more than 27 of 95. Okay. And there is so many more queries that I would encourage you to try out by yourself to get more insight of what Oracle Converged database can do for you. And with this one, I conclude my lab 7 and also it's finished for the session today. So if you have any question, please feel free to ask.
Thanks,
Okay.
Justin. I think we've covered all of the questions today. There were a few in the Q&A that have been covered. If you have any more questions, please do let us know and we'll get them answered and sent back to you. This recording, this session today has been recorded and will be sent to you following the event. We hope you found it informative and we look forward to seeing you at our next workshop. Thank you.